Welcome. This is a short video on how to order a mold from Atomic Compiler. It aims to show you what kind of mold you need to select to best meet your needs, and then show you what the casting process is like if you're unfamiliar. Just to give you a preview, here's an example of what you would start with. This is a bust of Benjamin Franklin in the form of an STL. You would send that to us, and you would get back something like this. This is a two-piece silicone mold. You would pour in some resin, and the exact type would vary depending on your needs, and you would get out something like this. Here's a casting of Benjamin Franklin. Now you can do this for artistic pieces, engineering prototypes, small production runs, restoration work, really a wide variety of things. This is a great approach if you're sort of in the middle in terms of scale. Generally, if you only need one or two of an object, you would just want to 3D print it. And if you need 10,000, then you would want to make a metal mold and you would want to do injection molding. But if you're in between, these types of molds are an excellent choice. Another nice thing about these types of molds, you can use these molds to cast all sorts of different plastic resins, wax, cements, plaster, really a wide variety of materials. You can make cast parts a lot more quickly than 3D printed parts. Some resins will cure in only 10 to 15 minutes. The parts are going to tend to be more durable than 3D printed parts. Also, the cost of the resin is generally much less than the cost of 3D printing supplies, so the per part cost tends to be less. You can also add fillers to the resin, so you can fine-tune the weight, the heat conduction, and if they're low-cost fillers, you can reduce the cost even further. So that's the background. If you're thinking this is the right process for you, let's dive into what you need to decide when you are ordering your mold. The first decision is pretty easy, and it's just, what material do you want the liner to be? There's three options. There's silicone. This is the most common option. Choose this if you're casting epoxy resins, urethane resins, polyester resins, molten wax, or thermoplastics. It's usually the default choice. We use platinum cure silicone, so it should last for quite a while, although these molds do eventually start to break down, usually after hundreds of uses. It's flexible, so your object can have some mild undercuts, although you do want to be aware that deep undercuts will make it hard to get the object out of your mold and will reduce the life of the mold. The surface is relatively non-stick, so it's easy to get your objects out even without using mold release. So it's the most common all-around choice. There are two specialized situations, though, where you would want to use something different. Now, if you're casting concrete, cement, or plaster, we recommend that you use a urethane mold because silicone molds can sometimes discolor the surface of the cast. We don't recommend urethane molds for any resin casting because the cast will be more likely to stick to the mold. So a pretty specific use case, cements and plasters. The other situation, if you want to make a silicone casting, you can't use a silicone mold. Silicone, of course, sticks to silicone. So in that case, you would use a urethane mold. The third option is to have a plaster liner. I don't mean casting plaster. For that, you would use urethane, but rather making the mold out of plaster. There's one scenario in which you would do this. If you're a ceramicist and you're doing slip casting, we can make the inner liner out of plaster for you. This is also a very specialized situation. If you don't know what slip casting is, there's a ton of resources online you can check out, but all I'll say is, unless you are making something out of ceramic, you would basically never do this. You also have to be aware that unlike urethane and silicone liners, the plaster is not flexible, and so you cannot have undercuts or it'll stick in the mold. So that's the easy decision. The second decision you have to make is around the geometry of the mold. There are basically three options that we offer right now: a one-piece mold, a two-piece mold with a planar parting line, and a two-piece mold with a non-planar parting line. Let's start with the one-piece mold. Here's an example of something you might want to use a one-piece mold for. It has one side that's detailed, and the back side is flat. You don't really care about the back side in this case. In this case, you can get an open-face mold, which is just one piece. And here's an example of what the mold actually looks like. You pour in the resin, wait for it to cure, and then pull it out. Pretty simple. This is the simplest, cheapest mold, but it's a good choice for a lot of parts. The downside, though, is that the back side is just open to air, so the resin may not cure perfectly flat, and it's really hard to get an exact thickness. So if you care about that stuff, then you want to get a two-piece mold. Here's the process. For this, I just used Quick Cast, which is a fast-curing urethane resin. It cures in like 10 minutes, and it expands slightly on cure. It also develops fine bubbles, so it turns white. This was some old resin that I had, and it was literally about 10 years old at this point, so I wasn't even sure it was going to work. But here you can see me mixing part A and part B, stirring it thoroughly, and pouring it in. At the end, it had already started to solidify because I waited a little bit too long, but whatever. This was just for demonstration purposes. And here we can see the final result, pulling it out of the mold. So that's an open face or one-piece mold. So now let's move on to the second type, which is a two-piece planar mold. Here's a second example. This is a bust of Benjamin Franklin, and we want to make a two-piece mold, and the parting line will be a flat plane. Now, this is going to have some undercuts, but they're relatively small compared to the overall size of the model, so it won't be much of a problem, assuming we pick our parting line well. Now, before submitting the STL to Atomic Compiler, we have to let them know where the parting line should be. So that's simple. You just orient your STL such that the XY plane is the parting line. The positive Z parts of the model will be on one mold face, and the negative Z parts of the model will be on the other mold face. So in this case, we have to rotate the bust and translate it so that half of it is above the XY plane and half is below, like this. Now, one other important point, where do you pour the resin in? Well, the top of the mold will be the largest value on the y-axis. So in this case, you can see that the base of the bust will be on the positive y-axis so that the part will be an open top and you can pour in the resin in there. Now for this particular bust, that works fine because we don't really care much about the exact surface of the base. But if you have particular needs for that surface, then you'll need to add a funnel and a sprue to pour in the resin and a riser to let the air escape, and then after it hardens, you trim those off with scissors or pliers. We'll talk about adding those in a second, but for this model, they weren't necessary. Then save that STL and submit that STL, and you'll get a mold that looks like this. Before the pour, you want to clamp the mold halves together. Now, if you have a really low viscosity resin, you might have a little leakage around the sides, particularly if the cure time is really long. So if you're worried about that, in addition to clamping, you can put some tape around the parting line to keep it from leaking. And then I actually will also put it into a plastic tray like this, so if it does leak, you don't get it all over your table. Now here we're pouring the resin into the mold, and here we are taking out the cured resin and the bust of Benjamin Franklin. You can see there's a little bit of flash around the parting line that you could clean up with a razor blade and some sandpaper, but overall it looks fantastic. Now the third type of mold is also a two-piece mold, but the parting line is non-planar. Now here are two examples of parts that you might need this for. So here we have a bowl. So a two-piece mold for this, we can't use a planar mold because we need the interior surface to come up here above the parting line. So there's no single plane that we could pick that would divide it correctly. Here's another example. This is a bracket with these tilted sides and a hole in the middle. Now if there were no hole here, we could cast it on its side and it would be fine. But if there's a hole and we did that, it would get stuck in the mold. So we need to cast it with the hole being horizontal. But unfortunately that means that we have some extremely deep undercuts for these two wings in the mold that are probably not going to work. So what we need is a mold where the surface of the mold contours up and contours down and follows those surfaces. So here's another case where we need a non-planar contoured mold. Now one very, very important point when you request a contoured mold is that it has to be completely unambiguous where the widest part of the mold is, and that will be where the parting line is placed. So for example, if you have a vertical cylinder, that actually won't work because the top edge of the cylinder could be the parting line or the middle or the bottom because they're all the same width. You need to add a little bit of taper to any cylinders or really any surfaces. They need to have a very slight draft so that one part of the part is unambiguously the widest, and that has to be a continuous line going around the part. If you don't have that, it doesn't work. Now in the case of this bracket, this hole in the middle is very slightly tapered in order to make it work. Now if we go back to the previous example, the one of the bust of Benjamin Franklin, we couldn't make a contour mold in that situation because there are parts of the pedestal and the head where the widest part will jump around. There are overhangs in multiple places, and so the program can't figure out where the widest part is or which one of those you want to select. So for that you just have to select for it and you just have to do a planar mold. Now here are the molds for the bowl and the bracket. So you can see the bowl has this part of the mold jutting upwards to make that inner surface, and the bracket mold is contoured as well. Now just for fun, I mixed up some plaster and I poured it into the mold of the bowl. I started mixing up the plaster in just completely the wrong proportions, and this mold actually doesn't have a proper funnel to guide the plaster in, so to be frank, it didn't really work that well. But you can see I did get a reasonable casting when I took the top off, although it broke when I went to remove it. That's because I used way too much water in the plaster. I'm actually surprised that it set up at all. Now that does lead me into the last thing that I want to mention, which is about sprues and risers. So you have to decide if you need a sprue and a riser, and if so, whether you want to place it yourself or let us place it. Now for best results on a lot of pours, you want to integrate a funnel and a sprue into your design. You pour the resin into the funnel and it fills the mold in a very nice controlled way. So here's an example of a part that benefits from a sprue and riser. You want all these surfaces to look nice and you don't want to see any evidence of the pour. So you add a funnel and a sprue here. This becomes part of the mold, and then when you pour in the resin, it goes down this sprue, it fills the mold in a very controlled way. And then you have a riser over here to let the trapped air escape so that the mold can fill. And then after it cures, you take it out of the mold and you clip it off here, and now you have your part. Now, if you need a sprue and a riser, we can put that on for you. We will place it so that it fills from the lowest point on your model and the air vents from whatever the highest point is. But it's very important to note, we recommend that you design your own sprues and risers. The reason is because we can't really know what you're pouring. If it's viscous and it sets fast, you need a fatter sprue so that it has time to fill completely. Or if it's slower curing, low viscosity resin, then you can use a smaller sprue. So it's really important, it's actually an important part of the design itself. We can slap on a generic sprue and riser, and it'll look like this. But there is an extra charge if we do that, and we really don't like to do that because we can't guarantee it's going to meet your needs. But if you insist on it, we can do it for you. Now, last thing to mention, if you have a really strange mold like a 4-piece or a 5-piece mold, you can send us your part and we'll send you a bid. It's not one of the standardized molds that we can just price automatically on the website, but if you just email it to sales@atomicpiler.com, we can take a look at it. And if you have questions, you can email to that address as well, and we'll see what we can do. So I hope this helps, and I hope it helps you bring your designs to life.